Welcome to another video. So today we have an interesting question from calculus where we are required to find the stationary points given that y is equals to x power 4 minus 8x power 2. So you're welcome. Watch up to the end until we find the stationary points, and if possible we're gonna sketch it. If you're watching us for the first time, kindly subscribe to this channel, turn a notification on, leave a comment. So on the solution part, you all need to recall that at any given point, at stationary point, of this type of curve or any other curve, always the derivative of y with respect to x should be equals to 0, meaning if I find the derivative of y with respect to x for this particular equation, I'm going to end up with 4x to the power 3 minus, of course, 16x. So that at any point, and you realize that for this quadratic, not quadratic, but x power 4 curve, you realize it's going to have at least 2 turning points, and so on. Next step. So next step, equating this to 0, I'm going to have 4x power 3 minus 16x should be equals to 0. And for me to solve this, I can either factor out x so that I end up with 4 to the x power 2 minus 16 is equals to 0. So this is a product of two functions. It's either x is equals to 0 or 4x squared minus 16 is equals to 0. So this case, for x is equals to 0, if I take x is equals to 0 and substitute in y, and wherever there is 0 and 0, I'm going to have y is also 0. So of course I have the first coordinate. The second, if you take 4x squared minus 16 is equals to 0, I can decide to divide by 4 across so that I end up with x power 2 minus 4 is equals to 0. For this question, you need to use the identity of a squared minus b squared. This can be expanded as a minus b multiplied by a plus b. So that rewriting this, I'm going to have x minus 2 multiplied by x plus 2 should give me 0. So it looks nice. So this is also a product of two functions. It is either x minus 2 is equals to 0 or x plus 2 is equals to 0. Equating this, taking this negative 2 on the other side, I'm going to end up with x is equals to positive 2, and this side x is equals to negative 2. So I have at least 3 values of x. X was 0, that one. X is this, and another x. So I'm going to call this one was x1, x2, and x3. So at x2, x is equals to 2. The value of y will be, I'm going to take 2 to the power 4 minus 8, 2 to the power 2. Of course, solving this, I'm going to end up with 16 minus 32, which gives me negative 16. So I have another stationary point, or the turning point in terms of its coordinate, that is 2, and negative 16. Let us see at x is equals to negative 2, substituting again in our original equation. Of course, when you take negative 2 power 4, you get 16. And when you take this, you're going to get 4. Negative 2 squared is 4 times 8. You also end up with negative 16. So that I have another stationary point, negative 2, negative 16. So next, I need to determine the nature. So let us try sketching the curve. And for me to find, I'll start by finding the y-intercept with the curve, meaning at y-intercept, of course, the value of x should be equals to 0, meaning if x is 0, as earlier on we have seen here, if x is 0, y is also 0. So when I sketch it, this is what it will look like. So meaning this curve cuts the y-axis at 0.00. That is y, and this is x-axis. That is it. Next, we've seen that this curve has two stationary points at 2. So if this is my 2, and the other side is negative 2, so the first one at 2, negative 16, when x is 2, let me say that is positive 16. And this is negative 16. So this curve is turning at 2, negative 16. So that is it. I can indicate it there. It is also turning at 0, 0, 0. So it is also going to turn there. And it is also cutting the y-axis at 0, 0. And then the same curve is also turning at negative 2, negative 16. Negative 2, negative 16 is there. Meaning, if I have to sketch it, this curve will turn there. Then it goes and turns there again. It comes and turns there. Like that. So it is turning at this particular point, this one, and this one. So using our eyes, we're able to see that this is a minimum point. This is also a minimum point. While at this particular point, it is our maximum turning point for that particular curve. So we have come to the end of this tutorial. I hope you've watched up to the end. Kindly remember to subscribe, comment, like this video, share it, and most importantly, you can subscribe. So until we meet again in the next video, goodbye for now.